Lag screws industry-wide are designed to allow for postoperative compression of the IT fracture. However, oftentimes this lateral migration is excessive, causing bursitis and discomfort in the postoperative patient. The Galileo lag screw was designed to combat this very issue. The outer barrel of the screw is designed to lock into the nail, while the inner portion is designed to compress internal to the screw. The gold portion is what locks the barrel into the nail, and postoperative compression is all internal to the screw. A look inside the screw shows that there are many components working together to make this possible. We'll explore each one of these individually. The locking mechanism of the lag screw is this ring housed between the gold and gray sections of the screw. The gold section is pushed against the gray section, closing the valley, so to speak, in which the ring sits, pressing the ring upward on all 360 degrees, locking it inside the lag screw hole of the nail. The telescoping feature is achieved as the threaded portion of the lag screw slides internal to the barrel of the lag screw, allowing for 10 millimeters of postoperative compression. This telescoping feature is spring-loaded for gradual and increased resistance during postoperative compression. Here you can see that the spring is positioned behind the threaded portion to allow for increased resistance through compression. The anti-recoil wedge is an O-ring of sorts, housed at the base of the threaded portion of the lag screw. It runs an interference between the threaded portion and the barrel, allowing the lag screw to compress only in one direction, preventing any recoil. In other words, it allows for movement in one direction only. There are 4 strong posts housed in the side of the lag screw. We call these the quad key design, and these prevent rotation between the threaded shaft and the barrel. The quad keys assure that the barrel and threaded portion of the lag screw move together as one unit. There are 4 pieces to the Galileo driver, and they're all found together on the very top of the instrument tray. These do not need to be put together in any particular order. In this example, we went from longest component to shortest, but the capturing rod goes through the driver, the locking T-handle goes over the driver, and then the compression sleeve threads all the way down to the black handle. It is extremely important that the lag screw be loaded properly onto the driver. This will ensure the proper function of the lag screw intraoperatively. Pull back slightly on the capturing rod so as to expose the hex end. Insert the hex end of the lag screw into the inserter and tighten the capturing rod to the extent that you can. On some occasions, the castle pieces, we call them, at the end of the lag screw do not line up properly with the driver. A slight turn of the black handle with a click will line those pieces up, and it's very important that you go back and tighten all the way down the capturing rod so that you have a snug fit with those castle pieces perfectly in line. This is the proper attachment. The lag screw is inserted through the sheath and the blue handle is turned to implant the screw. Here we see again that the quad key design assures that the threaded portion and barrel move as one unit. Compression is obtained by pushing the compression sleeve up against the jig, engaging the threads, and turning clockwise. It is important to note here that the compression sleeve is designed to limit the amount of compression you can do in one segment. The threads in the compression sleeve are designed to prevent overcompression, which would pull the locking ring lateral to the nail. You will hear an audible clicking sound as the threads in the compression sleeve have run out. As an additional safeguard, there is a red line in the shaft of the driver. When you see this line, you know that the locking ring is too far lateral to the nail. Do not attempt to lock the lag screw in this position, as the ring is too far lateral and the lag screw will not lock into the nail. We want to ensure that that locking ring is safely inside the nail. If you find yourself in this situation and you want to get more compression, following are the steps that will help you do that. Back the compression sleeve off by turning counterclockwise till it falls all the way to the T-handle. Advance the screw a few additional turns. This is why it's always a good idea to choose a lag screw that is 5 and even 10 millimeters shorter than your measured length. Re-engage the compression sleeve and turn clockwise until your desired compression is achieved. These steps can be repeated as needed for additional compression. When the desired compression is achieved, the lag screw is locked into place by turning the black handle clockwise until it is tight. Through this process, the gold portion of the lag screw is driven under the ring, expanding the ring on all 360 degrees. The lag screw is designed to be unlocked and relocked if necessary. To unlock the lag screw, pull back on the 2-finger plunger and turn the black handle counterclockwise. At this point, you may add additional compression if desired, and then relock the screw by tightening the black handle. The driver is removed from the lag screw by simply turning the capturing rod counterclockwise. In the event that the capturing rod is too tight to remove by hand, a hex driver can be used. To activate the post-operative telescoping feature of the lag screw, the activation sleeve must be removed. The activation tool is reverse threaded. Simply insert it through the sheath and turn counterclockwise until the activation tool is loose and then removed. Alternatively, the activation sleeve can be left in the screw to create a solid, locked construct. The screw is still locked in the nail, but post-operative compression or telescoping will not take place. The telescoping feature is now activated, and post-operative compression will begin as needed when the patient is weight-bearing. The barrel of the lag screw remains locked in place, and all post-operative compression is internal to the screw. Compression rests at any point between 0 and 10 millimeters, while the barrel of the lag screw makes no movement laterally. Additional information on the Galileo screw can be found at our website at aosortho.com. Log into the website for additional information such as full surgical techniques, fully animated surgical procedures, and other helpful information. In addition, you can always call your sales manager if you need further assistance.